Good morning students. In today's session we will discuss about the various steps in designing FIR filters, and we will start some of the problems how to design a FIR filter for a given specification. So, the last few sessions we have discussed about the FIR filters. So, the special features of FIR filters for the given system function, for the given system function h of z, the numerator polynomial which is a rational function in which the numerator polynomial summation of k is equal to 0 to m minus 1, it is a h of k into z power minus k, it is a can say is a bk coefficients. So, for FIR filter the system function which is equal to summation of 0 to m minus 1 h of k z power minus k. So, this is a numerator polynomial or zeros of the system. So, the FIR is a linear phase filter, it is a more stable filter, and in this FIR filter how to convert your infinite series into the finite impulse response by truncation, that is a windowing method. So, because of windowing method how the spectral leakage will be there. So, because of discontinuities there is a spectral leakage. If you see the magnitude characteristics of frequency selective filters, there will be some ripples in the passband and there will be ripples in the stop band. So, due to the windowing function there we can observe the ripples in the that is oscillations in the passband, that is ripples or the overshoot in the passband. So, which is more in the rectangular window technique compared to other cosine based window technique. So, what are the different window techniques are there? How do you convert your infinite sequence length impulse response coefficient into the finite one by multiplying mathematically by multiplying the HD of n with the that window function W of n. So, all these fundamentals we have seen in the last videos. So, now we will discuss how to solve for the given specifications, how to design a FIR filter for a given specification, maybe a low pass, high pass, band pass filter, or it may using alternate window technique, or it may be a cosine based window techniques. So, we will start. So, before start for a given problem, again we will refresh. You remember that what are the different various steps. So, the various steps, so we will discuss. So, various steps in designing FIR filters. Okay. Remember that FIR filter is a linear phase FIR filter, it is a more stable filter. The first step, choose an ideal characteristics, ideal frequency response, ideal, or you can say is a desired frequency response, that is h d of omega. So, mathematically h d of omega is equal to the summation of n is equal to 0 to infinity h d of n into e power minus j omega n. Okay. Let it be equation. Second one, second step, take inverse Fourier transform of this h d of omega to get the impulse response to get h d of n. So, mathematically h d of n, which is equal to 1 by 2 pi the integral of minus pi to plus pi h d of omega into e power j omega n d omega. Okay, this also you remember. So, the third step convert infinite duration this h d of n is an infinite duration to a finite impulse response, to a finite duration. The finite impulse response coefficients are nothing but FIR filter h of n. So, mathematically how do you get the infinite sequence, infinite impulse response coefficient into finite impulse response coefficient? So, the h of n is equal to by multiplying the h d of n with the window function. Okay. So, last class we have discussed what is window function. Window function means truncating your infinite sequence into finite sequence. The window function may be classification of window functions or rectangular window, or it may be other cosine based window, Hanning window, Hamming window, Blackman window, such. Okay. Then the fourth step, take Z transform of h of n to get h of z, to get h of z. So, h of n take z transform to get h of z, which is a system function of digital filter. System function of digital filter. Okay, the third step, convert infinite sequence into finite sequence by multiplying the infinite, that is the impulse response in the window function. This w of n is the window function. It may be rectangular or Hanning or Hamming. Okay. Similarly, the desired frequency response may be, this desired frequency may be low pass filter or high pass filter or band pass filter or band stop filter. So, for a given desired frequency response, determine the infinite impulse response coefficients by taking inverse Fourier transform. Then truncate infinite into finite by multiplying the window technique. Then next convert your h of n, the FIR finite sequence, into the system function h of z of a digital filter by taking Z transform. The next step, you have to realize the filter. Okay, realize the filter. So, realization, hardware realization with respect to your adder, multiplier and unit delay element. unit delay elements, because what we know that h of z is equal to okay, so that is h of k, h of z into z power minus k, okay, h of n into z power minus h of n, h of n into z power minus n, k into z power minus n, okay. Otherwise h in terms of k, if you take no, so here n is equal to, otherwise k, if you say the variable k equal to 0 to m minus 1, then this term will be h of k into z power minus k, okay. Realize the filter, which is a digital filter. Then finally, using h of n, you can obtain that is a magnitude of the functional frequency response h of omega for various values of omega in the range omega is not equal to 0, less than or equal to pi. Okay. So, if we see the rectangular window, for example, we will take first rectangular window, all the what are the different window functions for rectangular window, handing window, hamming window. In rectangular window function will be, so for example, m point, okay, rectangular window, m point rectangular window, w r of n, which is equal to 1, where the n is minus m minus 1 by 2, less than or equal to plus m minus 1 by 2, so 0 otherwise. How do you draw this one? So, with window function all 1, all will be 1. So, this is your window function, rectangular window function, w r of n. So, for example, w is equal to okay, 31. So, minus 15 to plus 15 is n. If you draw the spectrum here, there is a rectangular window, the frequency response. If you see this frequency spectrum, so the minus 2 pi by n plus 2 pi by n, this is omega. So, if you see this spectrum, it has two features. In this spectrum, it has two features. So, one is the width of the main lobe, this is called main lobe, this is called, these are called side lobes. The width of the main lobe is called the distance between these 2 points, okay, which is omega equal to 0, where the magnitude of WR of omega equal to 1. Okay, the width of the main lobe is defined as the distance between the 2 points okay, closest to W equal to 0, where this rectangular window, magnitude of rectangular window equal to 1, or you can say it's a 0 dB. Okay. So, the main lobe width is equal to this minus this, so you will get 4 pi by n, 4 pi by n. Okay. The side lobe, amplitude, these are the side lobes. Just a minute. Okay, excuse me. So, okay, we will continue how to design a filter now. So, these are the basic steps, the various steps to design a FIR filter for the given frequency response. Take HD of n by taking inverse Fourier transform, then convert infinite duration into finite duration by multiplying the rectangular window, then take Z transform to get a system function of digital filter. Finally, you have to realize the filter. So, the realization of filters will be with respect to adder multiplier unit delay element. So, now we will take one problem. So, problem is given. So, design. So, carefully you listen the steps. What is read the questions 1 or 2 times. Then, so what is the filter they asked to design? So, here the design low pass filter using rectangular window. So, if you write the window function for the rectangular window, if you draw the frequency response of low pass filter, then 2 marks will be given. Okay. First, what is the frequency response of low pass filter and what is the window function, rectangular window function. So, window function, rectangular window, by taking the samples are given 9 samples. By taking 9 samples, m is equal to 9, they given 9 samples of W of n, and the cutoff frequency, and with a cutoff frequency, the cutoff frequency of 1.2 radians per second. So, now we will start how to solve the problem step by step. So, what are the given parameters, given specification? So, WC is given 1.2 radians per second. Okay. So, given specification, second one, m is equal to 9. Step by step we will see. Step 1. So, first one is for a low pass filter. So, what is the ideal? So, step by step you have to explain ideal or desired frequency response, So h d of omega is equal to e power minus j omega alpha, where omega is minus omega c to plus omega c, 0 otherwise. Okay, this is for low pass filter. So step 2, low pass filter. You draw the desired frequency response of low pass filter. Okay, so what is it? If you don't remember now, you can write low pass filter. Okay, minus omega c to plus omega c. Okay, so omega is minus pi, this plus pi. This c is hd of omega. So what is c is 1. Okay, c is for rectangular window. So c, sorry, the desired frequency response of low pass filter. Okay, so minus omega c into plus from minus omega c to plus omega c. So e power minus j omega alpha, 0 otherwise. Step 2, yes dear. Step 2, take inverse Fourier transform of this hd of omega to get hd of n. Okay, so what is the formula? So hd of n, which is equal to 1 by 2 pi minus pi to plus pi. So this is hd of omega into e power j omega n d omega. Okay, the next step, substitute the limits 1 by 2 pi minus pi to, sorry, what is the limits for a low pass filter? What is the limits for low pass filter here? Minus omega c to plus omega c. So e power minus, this is, you have to substitute here. Okay, e power minus j omega alpha into this one e power j omega n. So this e power minus j omega d omega. Okay, step by step we show. So 1 by 2 pi, so minus omega c to plus omega c e power j omega common term n minus alpha d omega. Okay, the next step, take common terms, then 1 by 2 pi. So if you integrate, you will get e power j omega n minus alpha again divided by j into, with respect to d omega, you will get j into n minus alpha. So the limits are plus omega c and minus omega c. So again 1 by 2 pi. So this upper limit, you substitute e power j upper limit by j n minus alpha upper limit minus the lower limit. So e power minus j omega c n minus alpha by j n minus alpha. So, substitute the limits, integrate and substitute the limits properly. Then you take 1 by pi into n minus alpha outside constant terms, then the e power j theta minus e power minus j theta, e power j omega c into n minus alpha per j theta minus e power minus j omega c n minus alpha divided by 2 into inside 2 into j. Okay. Then which is equal to 1 by pi n minus alpha. So, sin term this is a 2j, no. So, sin, so you can write this sin omega c of n minus alpha. Okay. Now, when n is equal to alpha, see here, when n is equal to alpha, this term sin omega c n minus alpha by n minus alpha become 0 by 0 indeterminate. Okay. So, you can determine by using L'Hospital's rule. If it is not equal to alpha, if n is not equal to alpha, you can write the HD of n, and n is not equal to alpha, you can write HD of n which is equal to sin omega c n minus alpha by pi into n minus alpha. Okay. Okay. If for n is, when n is not equal to alpha, when n is equal to okay, when n is equal to alpha, okay, then HD of n can be evaluated, the HD of n can be evaluated using, can be, here I will write, can be evaluated using L'Hospital's rule. L'Hospital, what is L'Hospital rule? Yes. So, that is limit 0 which is equal to sin a theta by theta which is equal to a. Okay, this is L'Hospital's rule. You apply this and find the HD of n for n is equal to alpha, limits n tends to alpha, you will get sin omega c of n minus alpha divided by pi of n minus alpha. So, you incorporate this L'Hospital's rule and separate the terms 1 by pi, limits n tends to alpha. So, the numerator term sin omega c of n minus alpha by n minus alpha. So, this is a L'Hospital's rule I told, this is a L'Hospital rule. This is a L'Hospital rule. So, you apply this L'Hospital rule here. So, you apply here L'Hospital rule. So, you will get 1 by pi, this will be omega c, it is equal to omega c by pi. So, HD of n equal to omega c by pi for n is equal to alpha. Okay, this also remember. Okay. Next we will see step 3. This one. Step 3. Step 3. We will discuss with step 3. So now the impulse step 3 is the impulse response of FIR filter. The impulse response of the impulse coefficients, the impulse response of FIR filter is obtained. How do you obtain? By truncating your infinite impulse response coefficient into finite impulse response coefficient by multiplying the HD of n by window function. Okay. So, by multiplying the HD of n by window function. Here in the problem, what is the window technique is given? So, you have to consider rectangular window. So, H of n is a finite impulse response coefficients of FIR filter can be determined by multiply the infinite impulse response coefficient with the W of n window function, where here rectangular window. So, immediately what is a rectangular window? So, this is the third step. Okay. Next one, step 4. So, what is the not step 4, we will discuss here. What is the window function? You write here window function. So, rectangular window function WR can be written as, so 1 for n is equal to 0 to m minus 1. Okay. 0 otherwise for rectangular window function. So, WR is equal to 1 into 1 for n is equal to 0 to m minus 1, 0 otherwise. So, what is the m value is given in the problem? So, here since it is a rectangular window, it is a 1, no. So, since it is a 1, you will get H of n is equal to HD of n. So, 1 H of n for n is equal to 0 to m minus 1. Okay. Since it is 1, so H of n is equal to H of n only. H of n is equal to HD of n only. So, what is the m value? M value is equal to 9. Omega c is equal to 1.2 radians per second. So, what is alpha here? Then alpha is equal to m minus 1 by 2. Okay. So, m minus 1 by 2 for m is equal to r, alpha is m minus 1 by 2, which is equal to 9 minus 1 by 2, which is equal to 4. So, now when alpha is equal to, when n is equal to 0, when n is equal to 0, h of 0 will be, what is the formula? Sin omega c, sin omega c into n minus alpha by, okay, pi into n minus alpha. So, you substitute sin omega c value is 1.2. So, use calculator, put in proper mode, 1.2 radians per second into n minus alpha will be n is 0, alpha minus 4, substitute step by step, and pi into this is also minus 4. So, calculate the value, minus, you can cross check by using calculator, 0.0793. So everyone should know how to calculate and verify the answer. Okay, if you do any mistake in it, it will be wrong. Similarly, you find n is equal to 1. So n is equal to 1, so you have to find h of 1. So again similarly you write n is equal to 1, so 1 minus 4 minus 3. So substitute, I will write the answer directly, minus 0.0470. Similarly, when n is equal to 2, you will get h of 2. You have to substitute, simply do not write the answer, substitute properly and use calculator and write. Then n is equal to 2, you will get h of 2. So for that 0.1075. Then n is equal to 3, n is equal to 3. So h of 3 will be 0.2967. Now when n is equal to 4, what is the meaning of this n is equal to 4? N is equal to alpha. In this condition n is equal to alpha. Okay, n is equal to alpha. So in that case, what is that formula h of 4? What is h of 4? You have to write here. So if n is equal to alpha, so what is the hd of n? If n is equal to alpha, what is hd of n? Which is equal to omega c by pi, is it? So omega c by pi. So omega c 1.2 by pi, so which is equal to 0.3820. Okay, when n is equal to alpha, this is when n is equal to alpha. Okay, the next, when n is equal to 5, so h of 5 will be, again you substitute the same, you will get, see, h of 3 and h of 5. Okay, because see the symmetry condition, m is equal to 9. So what is the symmetry condition? H of m minus 1 minus n, which is equal to h of 9 minus 1 minus n. We will get h of 8 minus n. Okay, if n is equal to 5, h of 5. If n is equal to 5, h of 5 will be 8 minus 5, 3. So you will get h of 5 is equal to h of 3 only. So what is h of 3? 0.297. So h of 5 also 0.2967. You can write like this and this. H of 3 and h of 5 both are, because it is a symmetry condition. Okay, 3 and 5. Similarly, n is equal to 6. N is equal to h of 6 will be h of 8 minus 6, 2. H of 6 equal to h of 2. What is h of 2 value? H of 2 value is 0.1075. So this is equal to h of 6 also. Okay, so h of 6 is equal to h of 6 equal to h of 2 0.1075, 0.1075. Okay. Similarly, n is equal to 7. N is equal to 7. H of 7 will be, so h of 1. What is h of 1 value? This is h of 7 also. H of 7 is equal to h of 1. Okay, so 0.047. So 0.047. 047. Similarly, h of 8, next one is h of 8. So, in that case h of 0 will get. So, what is h of 0? Minus 0.0793, h of 8, okay, 0.0793 minus 0.0793, this is h of 8, 0.0793. Okay, since it is a symmetric and m is equal to odd, we will get the sequences h of 0. Now, you can find the magnitude response for this is a symmetric condition, symmetric and m is odd. So, you have to write the formula. What is the formula for symmetric condition? So, the real function, actually the magnitude function, this HR of omega is equal to, so h of m minus 1 by 2, h of m minus 1 by 2 plus 2 into the summation of n equal to 0 to m minus 3 by 2 h of n cos function cos omega of m minus 1 by 2 minus n. This is for m is equal to odd function. So, you can substitute here m is equal to odd, no, 9 minus 1 8 by 2 4. So, h of 4 plus, so these are the real function 2 into the summation of n equal to 0 to 9 minus 3 6 by 2 3 h of n cos omega of 9 minus 1 8 by 2 4 minus n 4 minus n. So, now you can write h of 4 plus 2 into, you can write h of 0, substitute n equals 0 to 3, h of 0 into cos 4 omega, okay, plus h of 1 into, plus h of 1 into cos 1, so 3 omega plus h of 2 into cos 2 omega plus h of 3 into cos 3 4 minus 1 cos omega, h of 3 into cos omega. Now you can write, simplify h of 4, okay, plus 2 into h of 3 into cos omega plus 2 into h of 2 cos 2 omega plus 2 into h of 1 into cos 3 omega plus 2 into h of 0 into cos 4 omega. Okay. So, finally, you can the transfer function step 4 is the transfer function h of z, it is a digital filter, the transfer function of the filter. This is the transfer function of digital filter. It is a digital filter is given by, so what is the equation? So, h of z is equal to the summation of n equal to 0 to m minus 1 h of n into z power minus n. Okay. So, here if you h of m minus 1 minus n is equal to h of n. Okay, remember that. So this you can implement here. So summation of n equal to 0 to 8 h of n into z power minus n. So since it's a symmetrical, you can write this, you can implement this one. So you can split the summation of n equal to 0 to 3 h of n z minus n plus h of 4 into z power minus 4 plus the summation of n equal to 5 to 8 into h of n into z power minus n. Okay, now this can be written as the summation of, so this can be n is equal to 0 to 3 h of n z minus n plus h of 4 into z minus 4. This can be written as plus, here I will write the summation of n equal to 0 to 3 h of 8 minus n z power minus 8 minus n. You can write, due to symmetry property, you can write this one. Now we apply this one, so it is equal to, okay, the summation of n equal to 0 to 3 h of n, common term you take, h of n into, so that is a z power minus n plus z power minus of 8 minus n plus h of 4 into z power minus 4. Okay. So this one to z power minus n. This one can write z power minus 1. So you can write this way. So now you know y of z by x of z equal to h of z, which is equal to h of 0 into z power 0, okay, plus z power minus 8, then plus h of 1 into z power minus 1 plus z power minus 7 plus 2 no, h of 2 into z power minus 2 plus power minus 8 z power minus 6. Z power minus 6 plus h of 3 into z minus 3 plus z power minus 5, 3 and minus 5 plus h of 4 into z power minus 4. Okay, so this is the final h of z function. H of Z is a digital filter. Then the final step will be hardware realization. Hardware realization using that adder, multiplier and unit delay element. These are the hardware components. Unit delay element. Unit delay element is nothing but Z inverse. Okay. So how to realize the system? So you can realize. So generally I told how to realize the system. The general realization of direct form of FIR filter. The last session I told that, for example, H of Z is equal to the summation of k equal to 0 to m minus 1. So, H of k into x of n minus k realization. Okay. So, this is y of n. Normally we can write y of n. So, this is in terms of transfer function. So, y of n I can write h of k into x of n minus k. In Z transform you can write h of z is equal to summation of k equal to 0 to m minus 1 bk into z minus k. So, this bk can replace with the h of n. Okay. So, you in order to realize the system, direct form realization, if you see the direct form realization of simple direct form realization of FIR system. So, this is where x of n. So, this is a unit delay element. You will get x of n minus 1, then x of n minus 2. Simply should not put 2 here. If it is delayed by 2, then one delay element represents only one. There is unit delay. This is unit delay element. Okay. It's delayed by 2 samples means delayed by 1, again delayed by 1, 2. You should not draw z per minus 2. Okay. So, here, so what is the function? Impulse function. This is h of 0, then this will be h of 1, this will be h of 2. So, again this will be z by minus 1. So, here h of m minus 2, so here h of m minus 1. Y of n. So, this is the direct form realization of FIR filter. Okay. So, I hope you understood how to design a FIR filter for the given specification. So, next session we will discuss about some other examples, high pass filter and some other window techniques, Hamming window. Okay. Thank you.